Welcome to This Explainer. Today, we're going to completely demystify coding. You know that brilliant idea you've had for a game, a tool, or maybe an app, but you just didn't know how to make it real? Well, today, we're treating programming exactly like constructing a building. By the end of our time together, you're going to see how coding is really just a structured way to take those abstract ideas floating around in your head and turn them into concrete, actionable steps that a computer can perfectly execute. Let's get into it.
Here is our blueprint for today. We'll cover why you should learn Python, how to set up your workspace, variables and basic operations, logic and decision-making, functions and loops, and finally, troubleshooting common errors. Kicking things off with part 1, why learn Python? Think of it as the ultimate translation tool.
And it's honestly no surprise you're here today. When surveyed, a massive 65% of viewers chose Python as the language they most want to learn over literally anything else. So why the hype? It's simple. Python is incredibly concise, highly readable, and massively popular. Whether you're looking to build a web application, design a game, or run complex scientific analysis, Python is this general-purpose powerhouse that sits right at the very top of the industry.
Moving right along to part 2, setting up your workspace, or as I like to call it, preparing your toolkit.
Now, sure, you could technically write your source code in a super basic text editor like Notepad, but man, that means absolutely no spell check and doing all your formatting completely manually. A dedicated IDE like Visual Studio Code is a totally different story. It gives you line numbers, beautiful color coding, really helpful auto-suggestions, and even built-in terminal execution. Honestly, it just makes you vastly more efficient. So let's actually define that crucial piece of jargon. An IDE, or Integrated Development Environment, is a software application that provides comprehensive facilities for software development. Basically, it's your master workshop where all of your programming tools are seamlessly brought together into one single powerful interface.
And the best part is that getting this set up is completely free, and it takes just 3 simple, totally non-intimidating steps. First up, you just download Python directly from python.org. Just make sure to check the box that says Add to Path during the installation. Second, install Visual Studio Code. And third, once you open VS Code, just grab the official Python extension. That's literally it. Your digital workbench is fully operational. With our workspace ready, let's jump into part 3, variables and basic operations. Time to lay the foundation. Now, before we go typing out our first calculation, we really have to respect the rules. Syntax refers to the specific grammar of a programming language. If you type something the computer just isn't expecting, like typing out the actual words, what is 1 plus 2, instead of using mathematical symbols, you're going to get a syntax error. Just like our spoken languages, Python has its own strict grammar that you absolutely must follow. But once you've got the grammar down, Python naturally follows the standard order of operations. You've got your standard addition, subtraction, multiplication using the asterisk, and division with a /. But Python also throws in some really neat tools, like floor division using 2 slashes to drop remainders, and the modulus operator using the %sign, which gives you only the remainder of a division. Pretty handy, right? So what if we want to save our data for later? Enter the variable. A variable is just a named container used to store different values or data types. Think of it exactly like a physical red bucket that you slap a label on. You can place a name, a number, or a specific tool inside that bucket and simply ask the computer to pull it out whenever you need it. And because Python variables are incredibly dynamic, they can change on the fly. If we use a single equal sign to assign the text string Kevin to our bucket, well, it holds that name. But on the very next line, if we write red_bucket equals 10, that 10 essentially kicks the previous value completely out. If you ask the computer what's in the bucket right after that, it's only going to tell you the number 10. Python doesn't even make you declare the data type. It just figures it out automatically. It's that smart. All right, moving into part 4, logic and decision-making. This is where we really start framing the structure of our code. To actually make decisions, we have to compare things using standard comparison operators. We can check if things are less than, greater than, or not equal to by using an exclamation mark. But here is the crucial thing to remember. Testing if 2 things are exactly equal requires a double equal sign. A single equal sign fills our variable buckets, like we just talked about, but a double equal sign asks the computer a direct question. Are these 2 values the exact same? Let's pose a real-world logic puzzle to see exactly how this works. Let's say my son Thomas is 3 years old, and the required age for kindergarten is 5. how do we write a flowchart of rules in Python to automatically tell us what class he belongs in based on his changing age? We do it using conditional statements. By utilizing if, else if, which Python shortens to elif, and else statements, we build a logic tree. The computer checks each condition from top to bottom. First, is his age less than kindergarten age? If yes, print preschool. If not, it moves down to elif. Is his age exactly equal to 5? If yes, print kindergarten. If neither of those is true, it falls back to the catch-all else statement and prints another class. The computer stops the exact moment it finds a true statement.
Okay, let's step it up a notch with part 5, functions and loops. It is time to add some automation. Think of a function as a reusable package or block of code with a designated name that executes a specific action whenever it's called upon. It is basically a modular powerhouse. You write a complex action once, you define it with a custom name using the def keyword, and then you just call that name anywhere in your script whenever you need that action done. No copying and pasting required. Here's a great example of how a function interacts with data. We define a function called add_10_2_age. We passed a parameter, in this case an age variable, directly into the function's parentheses. The function then takes that input, does the math, and uses the absolutely crucial return command to spit the newly calculated value back out to us. That way, we can save it or print it anywhere else in our code. Beyond functions, we also have loops, which are categorized mainly into while loops and for loops. Loops allow you to execute a block of code multiple times automatically. A while loop continues running as long as a certain condition remains true. Honestly, it's exactly like being asked to take out the trash every single week until a specific condition is met, like, say, you moving out. A for loop, on the other hand, is perfectly suited for iterating over a specific known range of numbers or a defined list of items.
Finally, we arrive at part 6, troubleshooting common errors. Every builder has to inspect their building, right?
The very first step in debugging is just knowing what kind of error you're actually looking at. First up, you have a syntax error, meaning you simply broke a language rule, like forgetting a quotation mark. Second is a runtime error. Here, the grammar is totally fine, but the code fails during execution, like if you accidentally told the computer to divide by 0. And third is the notoriously tricky semantic error. This is when the code runs perfectly without crashing, but the logical outcome is just totally wrong because of a hidden flaw in your human logic. We've all been there. And there you have it. You have successfully inspected the entire building process. You've just completed your 100-level fundamentals of Python. You now know how to set up an IDE, store variables, run logic, and automate tedious tasks. So I leave you with this exciting question. Now that you actually know how to communicate your intent directly to your machine, what incredible idea are you going to build next?